Find the radius of convergence for that function. How do we do it? We're going to do the ratio test. And what does the ratio test say? It says the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. Wherever the absolute value that's less than 1, the series converges. That's because, if the a sub n plus 1, that's the next term over the previous. If that's less than 1, that ratio, that means the next term is smaller than the previous term. The terms are getting smaller, so you can add them up to infinity forever, and you get a finite sum because they're getting smaller and smaller and smaller. The series will converge wherever that happens. So I say, okay, so let's find out where that happens. For what x values does that happen? I wrote x because I was saying x. Limit as n goes to infinity. All right, so what do we got to do? We got to do the a sub n plus 1 on the top here. So I'm going to plug in n plus 1 right there. I'm going to get 2 to the 3 n plus 1. Wait, I got to. There's the answer. We can, whoa, what happened there? I'll move this down a little bit so we don't get conflicted with the answer. See, it's 27/8, but why? So 2 to the 3 n plus 1, and then n plus 1 in there, times n plus 1 factorial to the third, and then n plus 1 in there is getting ugly. 3 times n plus 1 factorial. And this x to the n is over 1, so I'll put that in the top. X, again, plug in n plus 1 there too. All right, now I'm going to put that over. I'm going to go 2 to the 3n times n factorial 3, because it's a sub n plus 1 on the top, a sub n on the bottom, right? Over an x to the n here, over 3n factorial. Well, I don't want to do fraction over fraction. Instead, take that fraction on the bottom and flip it up, because dividing is just upside down multiplying. That'd be easier. So let's do that. So times, we'll do the other one. And what's the other one? Upside down. So 3n factorial over 2 to the 3n and factorial to the third. And the x's, this x to the n is on the top, but when we flip it down, it'll be on the bottom. Okay. Absolute, I want to know where's the absolute value of that coming out less than 1. Those are the places where it'll converge. Okay, so let's jump down here. Limit as n goes to infinity. All right, now we're going to do a little bit of math. That's what this class is about, huh? If I multiply right there, I'm going to get 3n plus 3, huh? So that means, what does that mean? That means that I'm going to need to write that as 2 to the 3n times 2 to the third, right? It's the same thing because, same basis, multiply, powers add, 3n plus 3, 3n plus 3. Why am I doing it that way? Because I want that 2 to the 3n to cancel with that 2 to the 3n. You see the method to my madness? Okay, now what about this? N plus 1 factorial. That means n plus 1 times n. Oh, let me try that again. Factorial, all raised to the third power. You good with that? Because that's like saying 7 factorial is the same as 7 times 6 factorial, right? Because 7 factorial means 7 all the way down. So that's 7 times 6 all the way down, right? So n plus 1 factorial is n plus 1 times n factorial. Now they're both to the third power. So I can go boom, boom, put that third power in both of them. So I can say this is n plus 1 to the third power and n factorial to the third power. Let's do that. N plus 1 to the third power and n factorial. Now, why am I doing all that? Because I want that n factorial on the top to cancel that n factorial to the third power on the bottom. You see? And then down here, this distributes. This is 3n plus 3 factorial. So what's that? That's 3n plus 3. 3n plus 2 times 3n plus 1 times 3n factorial. Why that? Again, that's like taking something like 7 factorial and saying, well, look, that's 7 times 6 times 5 times 4 factorial, 4 all the way down, right? Because this means 7 all the way down. So you can peel off 3 of them, or however many you want, and then say the last one all the way down. That's what I did. Now, why did I do that? Because I want that 3 in factorial to cancel with that 3 in factorial. You see? And then times. All right. Now let's just write the other one, and then the good stuff will happen. Cancellation time. Oh, the x's, you know what's going to happen here, right? This is x to the n times x to the 1 powers add x to the n cancels x to the n. So I'm just going to put there's an x to the 1 left on the top. Like good. On the bottom, 2 to the 3n n factorial cubed. All that absolute value. Where is it less than 1? Because that's the place where it converges. Okay. Now comes the happy step. All this ugliness. Most of it will go away. So 2 to the 3 in. 2 to the 3. I'm going to cancel or circle everything I can. In everything. In factorial cubed. Those are gone. Okay. 3 in factorial. 3 in factorial. Those are gone. So what are we left with? 2 cubed. Um, yeah. And then I'm going to put I always put all the in stuff together. So 2 n cubed over 1, I guess. Then I'll put all the n stuff together, which is what? N plus 1 cubed, circle that, over 3n plus 3, 3n plus 2, equals 1, right? Boom, boom, boom. Now, is everything circled or crossed out? It is. Everything circled or crossed out means, oh no, except for the x. See, it's good I have that. Circle that. So x, absolute value, less than 1. Okay, so circle or cross out everything. So now what is all this become? Much nicer now. Limit n goes to infinity. Now 2 cubed, that's 8 times, right? 2 times 2 is 4 times 2 is 8. Now when you're going to infinity, remember all that matters the most powerful term? So infinity plus 1, that 1 is not important. And this plus 3, this plus 2, this plus 1, they're not important because you're going to infinity. If you have 3 times infinity, add 3, the add 3 is nothing. Now, the 3 multiplied matters, right? Just think about if you're plugging in, n's going to infinity. What if you're just plugging in like a million? 3 times a million, that's 3 million. That's a lot more than a million. That matters. But plus $3, nobody cares, right? Plus the numbers added don't matter. So where does that leave us? N cubed on the top, and on the bottom, 3n times 3n times 3n. Absolute value. Where is it less than 1? We're getting close now. Limit n goes to infinity of 8 over 1 times. Now what's going to happen here? This is n cubed. 3n times 3n times 3n. That's 27 n cubed less than 1. Bye-bye. Whoop, almost. Sorry, cancel out that 27. So, oh, did I lose my x? Hey, x, where'd you go? Where'd you go? You're there too. Here, I'll just stick him in wherever, right there. So 8, 27 x. No more limit. I did the limit. It's gone. And so now multiply by 27 over 8 on both sides. Bye, 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 bye. Absolute value of x is less than 27 eighths. As long as the absolute value of x is less than 27 eighths, which means x is between negative 27 eighths and positive 27 eighths, that's the radius of convergence because, from the 0 to the right or the left, 27 eighths, radius means from the middle to the edge. The radius of convergence is 27 eighths. As long as the absolute value of x is less than 27 eighths, that series will converge. Is that the answer they had up here? Ah, that's a beautiful thing. We got it right. There we go.